Hi there, I'm Chris Saxon, the SQL Wizard, and today we're going to take a look at a question that many people have when they first start tuning SQL queries. Why has Oracle chosen a full table scan instead of my index? What's the factors behind that decision? We're going to take a look at this, but first I'm going to talk a little bit about chocolate. I have here loads of bags of sweets ready for my daughter's party. And I also have my document listing the colour of each sweet and which bag it's in. Now, my daughter's quite particular and she's decided she wants all the red sweets to herself. So what I need to do is go through all these bags, pick out the red sweets and leave all the others in the bags. There's a couple of ways I can do this. Let's take a look at them. The first approach I'm going to take is to just pick up a few bags at a time and then go through them, looking at every single sweet to see whether or not they're red. So I'll pick them out. First sweet, blue, orange, no, don't want those. Then we've got a brown one, no, don't want that. Red, got one at last. Keep going until I've found all the checked all the sweets in this bag and these other two bags here. Once I've finished these 3 bags, put them down, and then pick up another 3 bags. Repeat the process. Look through them, checking every sweet to see whether or not it's red, until I've done all the bags. The second approach I can take is I can use my document here. And what I can do is go down the document, navigate to the red section. So we start at the top. First red sweet is in bag 12. Go to bag 12, pick it up, find the red sweet, pull it out, if I can find it, there we go, pick it out, and then I need to go back to my document to find the next red sweet. Where's that one? It's in bag 3, okay? I'll go to bag 3, pick bag 3 up, open it up, get the red sweet out, the red candy, there we go, got it, put bag 3 down again. Go back to the document, bag 5. Bag 5, pick out the red sweet, and so on. I'm continually going backwards and forwards between my document here and my bags, picking up one bag at a time, picking out the sweet, and then repeating the process for the next row. So we've seen a couple of ways why I can use to find all the red sweets to get for my daughter. This is very good, but what's it got to do with Oracle? Well, as we saw in the previous episode, this represents a table in my database, and each individual sweet is a row stored within that table. The document here is an index on the color column of that table. Now, something I haven't discussed yet is the significance of the bags, and these represent what is called a block in Oracle. Just like all the sweets, I put all the sweets into a bag, Oracle always stores rows within a block. And the number of rows stored in a block are determined by factors including size of the block, default's 8K, and the number of columns and their data types in the table. But typically you'll have a large number of rows in each block, just like I've got many sweets within each bag. So with that in mind, what are our 2 approaches? Well, the first is like a full table scan, and the second is analogous to an index range scan. With that in mind, let's take another look at the 2 approaches. With my full table scan, I'm able to pick up several blocks at once in what Oracle calls a multi-block read. However, with my index range scan, I'm only ever picking up one bag at a time, continually going from my document, looking at which bag it's in, which block it is, picking that one up, and then going back to the document, and then flicking to another bag. With 3 or 4 red sweets in each bag, I'm typically having to pick up each bag 3 or 4 times. So if we compare the work, visiting each bag once for my full table scan versus 3 or 4 times for my index range scan, the full table scan has much less work, so is more performant in this situation. Does this mean full table scans are always better? Of course not. Let's take a look at another scenario. I placed a silver sweet in one of the bags, and whichever child gets that bag wins a prize. However, I've forgotten which bag I put it in, so I want to go through the bags and find it. Let's take a look at how the performance compares of my full table scan versus my index range scan in this scenario. So with my full table scan, I'm still having to visit every single bag. I'm still picking them all up, looking at every single row, inspecting them to see whether they're silver or not. Now, you might say, I know there's only one silver sweet. Why don't I stop as soon as there's one? I find it. Well, someone else might have slipped one in, and I just need to be sure there are no other silver sweets there. So I'm still looking at every single row in every single bag. However, using my handy document here, I can just go to it, to the silver section, find the location of the silver sweet. It's bag 3. I go to bag 3, pick it up, pull out the silver sweet, and I'm done. So in this example, we can see the index range scan, it performs significantly better. I only have to do one bag operation. I only access one bag. However, my full table scan is still visiting every single bag. This is significantly more work. So the key thing here is that the full table scan does a constant amount of work, whereas an index range scan will do an amount of work that's proportional to the number of rows that it has to access. So where's the crossover point? When does a full table scan become more efficient than an index range scan? Basically speaking, when it does fewer I/O operations. Now, in this example, I've got 16 bags, and the full table scan will read all 16 of them. Now, when I was reading the information out of my index here, each new entry in the index, so each color, was in a different bag to the previous entry. So when I was reading the first one, picked up this bag, second one, I had to go to a different bag. This means after selecting just 16 rows, I had to do 16 I/O operations. So in this case, the index range scan is becoming less efficient, roughly speaking, when we're selecting 16 or more rows. However, in saying that, I made a very important assumption about how the data is stored in the index relative to how it's stored in my table. And we'll take a look at that in the next episode. I'm Chris Saxon. Thanks for watching. Thanks for watching. I'm Chris Saxon, the SQL Wizard. Subscribe to my YouTube channel to get future updates on more SQL magic. I'll see you next time.